our next concept here, permutations with repetitions. Permutations with repetitions, like suppose we have 5 apples to be distributed among 4 boys. I am taking one example to make this concept clear, that suppose we have 5 apples and we are going to distribute that 5 apples among 4 boys. Then apple 1, 2, 3, 4, 5, and there is no such restriction that a boy may not get more than 1 apple. So boy 1, so apple 1 can be distributed in 4 ways. Apple 1 can be distributed in 4 ways. Same way apple 2. Now there is no restriction that suppose boy 2 got first apple, then there is no restriction that boy 2 cannot get the another apple. So there is no such restriction. So repetition is allowed. So now apple 2 can be distributed again in 4 ways. Apple 3 again in 4 ways. Apple 4 again in 4 ways. Apple 5 again in 4 ways. So total number of ways 4 to the power 5. Total number of ways 4 to the power 5. So the concept is n to the power r. And total number of objects are objects at a time. One more example. Suppose we have all things means all the things are not same. Like suppose we have, he said find the number of arrangements for this. Now A are identical, but B is different. B and B itself are identical. These two are identical. C is different. D. These are identical. Find the total number of arrangements. 3 to 5 and 5. We have total 10 letters given. If there is no such condition that these 3, these 4 are identical, then number of arrangements are 10 factorial. In case we have all objects different. Now some of the objects are identical, then concept is, now see, if this A will be here and this A will be here, this A will be here and this A will be here, right? If these two A's are not identical, suppose this is A1, A2, A3, then arrangement is changed. If these two A's are not identical, these two A's are different, A3 is here, A1 is here, A2 is here. If these are interchanged now, then arrangement is different. But when these three A's are identical, then if this will be here, this will be here, there is no difference in the arrangement. So as we have total taken 10 factorial arrangements, but these three are not making any difference if they are changing their positions themselves. These two are not making any difference. These 4 are not making any difference. So divided by the number of arrangements of their own, that is 3 factorial for A's, 2 factorial for B's, and 4 factorial for D's. Number of objects which are identical. So we have a concept here of total n factorial divided by p factorial, q factorial, r factorial, or as many number of times the relate that objects are identical. So this is the concept. Just note it down.